Welcome to the Uptime Wind Energy Podcast. We have an excellent show ahead for you. Mitsubishi created a solvent that can remove almost 100% of CO2 from large industry emissions. And then GE and Siemens Gamesa have been in a court battle, and it's coming to a close, and GE is in trouble.
And then we have a couple of projects from Orsted. They're planning to reduce emissions from their steel supply. And also they have another interesting project with Newcastle University in Australia to seed coral on Taiwanese offshore wind turbine foundations.
Stay tuned. We'll be back after the music. Mitsubishi, of all companies, has created a solvent that takes CO2 out of the air. And they're calling the solvent KS21. It's a trademark, actually, KS21. And it's the summation of almost a decade's worth of work by researchers. And I think this is actually happening up in Norway. So they're testing this in Norway. But it improves carbon capture efficiency or carbon dioxide capture efficiency from existing about 90% to practically 100%, which is remarkable. So the way this system works, and there's a really cool YouTube video that explains it, they have the solvent and they have the emissions coming up the flue with the CO2. The solvent grabs the CO2 and it, I'll use a chemical term, precipitates. So it all falls to the bottom. And then they pull that solvent plus CO2 out, break the solvent and the CO2 apart using heat, it looks like, and then they just capture the CO2 and store it, and then eventually turn it into rock, bury it. So in a sense, they've created a system in which doesn't require added solvent. Once you have the solvent in place, it's totally recyclable, and they can pull nearly 100% of CO2 from industrial sources. So if you think about it, a steel plant or places where you really have to use a lot of CO2 to make things like steel, you could essentially bring the CO2 emissions almost down to zero. That's crazy. And they're saying that it's holding. They're looking at a couple places: heavy transportation, steel, and concrete as being the big drivers here. So if the system works, you could actually put it on trains, or you could put it on, in theory, like aircraft. That's crazy, right? Is this something you ever heard of before? Because it's completely new to me.
I have a lot of questions more than answers. So I think the first thing to note is that you can already remove like essentially 100% of carbon dioxide if you want to, if you're prepared to spend enough money and energy to do so. And in a lot of processing, like air processing industries or like natural gas, when they're turning that into LNG, they need to remove all the CO2 because otherwise it will freeze out before the gas liquefies and ruin their equipment. So they have a really strong financial incentive to remove it all. And they do. They manage to remove it all in that case. The only place where we don't manage to achieve, the reductions that we would probably like to see is where you're removing CO2 for the purpose of keeping it out of the atmosphere, because there is no financial incentive to do that. That you don't pay anything to put CO2 in the atmosphere. So why would they spend the money to do it? And when you do, it's like a lot of engineering processes, getting to 90%. You can do, maybe quite cost effectively. Getting to 99% costs a whole lot more than that. And then getting to 99.9%, like the more nines that you get, the exponentially more expensive that it gets. And that's generally due to just the amount of residence time that you need for these reactions to take place. It's like... I'm no chemist, and it's been a little while since I did my video on this technology, but basically, there's a reaction happening, and at the start of the reaction, there's a whole lot of molecules there ready to grab CO2 out of the solution. And then, as time goes by, there's less CO2 in the solution, and so it takes longer for a CO2 molecule to, hit the thing it's trying to react with and precipitate out. So,
Sure.
In the end, you need really long times or big vessels to get to the really high levels of removal. So if they have some way that they can get all the way to very close to 100% without needing a massive vessel, then that would be definitely a significant advance. Because currently, like if you look at a coal power plant or any kind of power plant that's got CO2 removal on it, the CO2 removal equipment is some of the biggest kit on site, right? It's humongous, these big vessels that they need to run the process. And it uses a lot of energy, maybe 30% of the energy that the power plant is generating will need to go back and, power the CO2 removal. So, I haven't seen it's interesting, like what you call efficiency. It's removing with 100% efficiency, which they are intending means they're capturing all the CO2. That's not brand new or impossible. What's the energy efficiency though? If you put it on a power plant, how much of that power plant's output needs to actually be diverted to power the CO2 removal? And then if they're really going to put it on transport, which is definitely something I have never heard anybody with a process that they remotely thought could be fitted on transport. I mean, the question then is not just how much energy it's going to use, but how big is it going to be? And are they still getting that 99 point whatever percent removal at the scale that they can plausibly put on a truck or a train? Or, I mean, it's not going on airplanes. Surely ships. Ships would probably be maybe the easiest place to put it because mass doesn't matter, space doesn't matter nearly so much there.
Doesn't matter so much, right? Well, yeah, because the marketing people for Mitsubishi put out a statement. And this is a quote from one of the marketing people. It said, "I think most people still don't truly understand how important this breakthrough is for the future of CO2 capture and the decarbonization effort globally." I think that's a very true statement. If it does what we think it does, and like you said, if it doesn't use a lot of energy to repeat the cycle, that would be gigantic. I think you're right. It's a question of how much energy.
I suspect it's not the hugest breakthrough. Otherwise, I feel that I would have heard of it already. Because that's the real problem that I have with talking about carbon capture is that it's always, like the company that has the innovation, the technology or the product, they want to make it sound sensational because they want attention, because they want to raise funds. But when you make it sound sensational, it's always done in a way that makes it sound like this is, instead of decarbonization kind of thing, carbon capture, it has that risk that it makes it sound like, why would you bother doing anything else in the energy transition when we've got carbon capture now? So all you need to do is just emit as you were, just continue business as usual, and we'll just suck it all out of the atmosphere, or, in the case of direct air capture, or in case of this one, we'll all don't worry about electric vehicles, don't worry about renewable energy, because there's a new technology coming that, is just going to make that problem go away. And the carbon capture technologies that we have for now are definitely not close to that level, especially because of the energy use. It's you make the problem worse. The more of these things that you install, you're increasing your your energy needs by 30%, which means emissions by 30%, and so it's kind of like diminishing returns. And the other thing is that you often see, like in reporting on all technology, but especially clean energy technologies, they never really give you a sense of how much development time is left. And, in the case of carbon capture, I'm really glad people are researching this because, come 2050-ish, we're going to need that for the stuff that you just can't decarbonize, which will...
That's right.
I don't think that will include steel. We can talk about that more later, but that's going to include, some aspects of agriculture and some natural processes. If we've already started off permafrost defrosting, then that's going to be, some big big emissions coming from that, and we're going to need carbon capture for those sorts of things. So I'm 100% on board with research and development of carbon capture, but where it gets tricky is in the reporting of it. I think it's so important to make it really clear what are the energy costs of this. If the energy costs are high, it's never going to be instead of decarbonisation. It's going to be for specific use cases. And I know that these the spokespeople from this company are saying that. So it's they're not saying this is going to eliminate the need to decarbonise. They're saying this is going to be for the hard to decarbonise industries, which implies it's going to be expensive and energy intensive, or at least one of those two. Yeah, and the other thing is you just got to be really honest about how much time is left before you can plausibly commercialise this. And that's something I've been talking about a bit recently on my channel. It takes very often 20 years after the really exciting science has happened, which is probably where they are here. Yep. Exciting science, cool. It's probably 20 years of engineering before they have a chance at rolling this out on a industrially meaningful scale. And I think if you're not honest about that, it can give people the impression that this is, some sort of silver bullet solution and really get in the way of all the other stuff that we need to do in the meantime, the technologies that exist now. Yeah.
Well, I think there's two good things going in this news piece, which is one, it's Mitsubishi. So Mitsubishi doesn't tend to exaggerate too much. They pretty much are straight shooters from all my experience with Mitsubishi. And the second is they have been working on this for 10 years. So I like you, think it has to be developed for probably a good 5 or 10 years. And having done that myself a couple of times, you see it's like, oh yeah, it's a 10-year development cycle just to get it to the point where they can marketize it. So they're there. So it's not new. It's just maybe it's reached the maturity point where they can start talking about it. And they have been doing this demonstration site up in Norway. Those are all good indicators that maybe this technology is worth looking at, and companies or people like Elon Musk and some of the Google families that are throwing money at carbon capture may want to take a look at something like this, because this may be your biggest bang for your buck if it doesn't use too much energy. And Rosemary, you're right. I think that the missing piece in this news release is how much energy it take to make this chemical cycle go. More to come.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
All right, Rosemary, your old employer is going through a huge battle with Siemens Gamesa.
Yours too, right?
And well, it is mine too, actually. But I didn't work in the renewable energy part of it. I worked in the spacecraft part of it from years ago. But GE and Siemens Gamesa have been locked in a patent battle. So GE was suing Siemens Gamesa for a particular patent infringement. Siemens Gamesa came back and said, well, you're infringing on our patents. And it turns out that Siemens Gamesa got a court to agree. So now GE is kind of in a bind. So back in June, a court in Boston agreed with Siemens Gamesa that GE has infringed upon one of Siemens's patents having to do with sort of bearings and structural supports around bearings and their direct drive platforms. When you go, well, direct drive, that's Haliade, right? That's what it is. So the court is now progressing into this penalty phase, which is the worst and probably the scariest part of any patent litigation is what is some judge or jury going to lay out for the amount of penalty you're going to pay for this. What Siemens is pushing is $30,000 per megawatt. So most of the Haliades, offshore Haliades, are like 12 megawatts. So you're talking about $360,000 per turbine sort of penalty. That's a lot of money. That's a lot of money for a patent infringement. Now, that's where it starts to get really heated. So if you can think, well, the Haliade is going to be used on Vineyard Wind, the next real big wind project offshore in the United States. And there's a couple of others. There's one Ocean Wind down in New Jersey, or two relatively new projects. What's GE going to do? Is Siemens going to let them put Vineyard Wind in? Now, what it seems like at the moment is Siemens is saying, hey, there's 62 wind turbines that is going to go in Vineyard. We're going to let you do those. We're not going to penalize you. Like those 62 you can do, but not a turbine more. It's not 63. It's not 64. It's 62. So you can make that many. After that, you have to stop. Now, as you can well imagine, you're playing in big-time politics in the United States. And in terms of offshore wind, there's a lot of state involvement. So the state of New Jersey gets in front of the court recently and says, hey, you can't shut us down. We're trying to create offshore wind on the state of New Jersey. We have this big project going on. If Siemens shuts down GE, we're stuck. And we've got millions and millions of dollars. I think the Vineyard has already paid GE like $150 million. So there's a huge pile of money here. I don't see how this ends happily. And Rosemary, does this even make sense for Siemens to push this hard on GE? Let's just say GE is guilty, whatever that is, whatever you feel like. But $30,000, basically $350,000 to $400,000 a wind turbine as a penalty. Does that seem commensurate with the infringement?
It seems like a lot. I mean, you can buy a big chunk of a wind turbine for that amount of money. I mean, obviously these are huge offshore wind turbines, so like even each blade would cost more than that, I'm assuming. But it's not small. Haven't you love trawling through patent databases? Haven't you looked up the patents and had a look?
Just briefly.
It just sounds so benign.
Mechanical.
Yeah, it really doesn't sound like the sort of thing that I would imagine there being an exciting patent on an offshore direct drive turbine structural support mechanism and the physical and structural arrangement of the main shaft bearings. I mean, that's so boring. It's incredible. It's incredible to me that has such a valuable patent associated with it, a design detail like that. And of course, it's a huge stuff up on the part of GE. And I know that they have a very proactive legal team. When you're working on a new design, then you will, as a project managing new technology, product development, and you will sit through hours and hours and hours of meetings with the GE patent attorneys to troll through any possible remotely similar patent that could cause problems. So I don't know if they missed this one or if it's really I can't understand the language. I could never do interpretive. I could never do that on my own. Yeah. You need the lawyers, you need the engineers there to understand what on earth the patent means and if it's similar to yours, but you need the legal team there to, interpret the language. And there's always, you're reading the patents and it's, this is the primary claim and, they say all this stuff in there. Is that actually an intrinsic part of the patent or is it just peripheral? Yeah. Is there prior art? Yeah. Blah, blah, blah. It's so incredibly boring for an engineer. I'm sure patent attorneys love it. Otherwise, they'd do something else for a living. But it's incredible that it's gotten this far. I've never had anything I was working on, never had a problem. So I don't know what a normal amount to award is. But your question about is Siemens right to push it? I mean, I would push it if I was Siemens. That's what these companies have. Yeah. They have their intellectual property. They, if you don't enforce it, why is anybody innovating? You kind of need it to be enforced to keep the whole system working. It's tricky.
Isn't there an off-ramp to this in the sense of I think Siemens can get their pound of flesh. I'm totally fine with that. But you can't doing this forever because at some point GE is going to have to either redesign it or pay something to Siemens that's a reasonable amount. Those are your two options, really.
Yeah, so I think that GE and Siemens should be able to get together and work out an arrangement because if GE has no choice but to redesign, then Siemens doesn't get any money anyway. They get some extra sales while GE isn't able to sell anything. That's about it. So I guess that is why they have made this initial concession on the first 62 turbines. But I think that, GE and Siemens need to get together and say, there would be an amount of money that GE would be prepared to pay rather than redesign. Siemens would, probably want to find what's the maximum amount that is and hit it. They need to get around a negotiation table and see if they can find a deal.
It seemed like Siemens' initial starting point was GE has to cease and desist. And I get that as a bargaining point, that you have to start there because you're not likely to end up there. But it seems like there's a big disparity right now. And when the U.S. sees it as a national interest, and I think at this point, GE can make the argument that it's of the national interest and of states' interests to petition the court to either lower this thing or to make it go away. Now Siemens may have all of a sudden a weaker case, right? If the president of the United States says, "Hey, this is going away," I think they can do that. I think they can make life miserable for Siemens if they wanted to in a myriad of ways.
That's so un-American.
I don't know if you want to do that.
That will never happen. I mean, it's no one pursues intellectual property rights more than the US, right?
That's true. But it's not a U.S. company. See, that's the piece.
Yeah, but then that's like, do you want foreign investment in your country, or do you want to, become this isolated country that only uses U.S. technology? I think that you'll suffer more for that that perspective than
I'm not arguing
what you've got now. Yeah.
I as a patent holder, you're a patent holder too, right, Rosemary? You have patents.
I've got I'm an inventor. I have my name. I was the inventor of patents. I don't own them. But yeah. Yep. I'm technically an inventor like you.
Right. So you're part of the large inventor family, right? So we always feel you're part of the club. You're part of the in crowd.
Yeah.
So you feel really protective of your intellectual property, and intellectual property and patents are part of the U.S. Constitution, so it's a big deal in America. I totally agree with you. I'm on your side with this. Intellectual property rights are ultimately the thing that shouldn't be touched by government. But the reality is that if push comes to shove and it gets to be a big deal, I could see where I guess there's a couple ways they could do it. The federal government could just write a check to GE and say, "Hey,
isn't that a better way? Isn't that better that they they just chip in some money? Okay, we've had a cost blowout on this particular project. We'll chip in some money to to cover that. Now move forward." But yeah, I think intellectual property is really interesting problem because it both accelerates innovation and hampers it at the same time. You know, so any time you look at an individual case of patent infringement, you almost always feel sorry for the person that infringed if it was, accidental, which, in the countries that are developing the products that we deal with, that's usually the case. They're not doing it on purpose. But on the other hand, so it sounds like, okay, everything should just be open and then we'd be able to move faster if we shared all the knowledge. And that sounds like a really nice idea. But then you think, well, why would the first person invest millions of dollars into the development of something? And then once they've made all the expensive mistakes and figured out how to do it, somebody else just comes along, doesn't have to spend that money. That puts you at a disadvantage for having been the one to innovate. So you can't have that either. I think that one interesting model is, Google's, Alphabet, I guess it's the other way around, Alphabet owns Google, but, they invest in a lot of new technologies. And they had one, Makani airborne wind, for example, that I've looked into a lot. And they stopped developing that because basically the economics weren't going to work out for them. But when they give up on a technology, they release all the IP to the public domain. So, if you want to develop an airborne wind system, you can go and have a look at they got all this data from, like test flights and everything. And you can see what they've done, and they've promised that they're not going to, launch legal action if you use one of their patents and stuff like that. So that's kind of one... that's one model that you can kind of maybe get a bit of the best of both worlds.
Right. Yeah. Oh, yeah. Absolutely. So I think your point about how many patents or patents there are on a wind turbine, and then making sure you don't stumble into one, is true. If you look at the number of, and we talked about it, I think it was in the previous episode, we talked about it, how many patents there are. There's a lot of patents related to wind. So if you have to sift through all of those and make sure you haven't infringed, that's a full-time job for a number of people just to do that, and to stumble across one accidentally, I think is totally likely. But I think the thing you're seeing in editorials right at the moment is that, well, GE brought it upon itself, because GE was very aggressive going after other companies that have infringed on their patents and getting the royalty payment. So it became a sort of a little bit of a cash cow for them. And I think the feeling is that a little turnabout is fair play. So Siemens is going to get their, is going to have their whack at GE here. And the industry is like, well, GE kind of deserved it. I disagree with that, but I think that's where some of the industry is going. Well, GE is just going to have to pay for it. And yeah, I get it, sure. But it is very complicated. It's not as cut and dry as some of the news reports put it out to be. It is, as you and I know, making sure you don't stumble across somebody's patent that's, like you're saying, something that's a mechanical support deep inside a wind turbine generator. The chances that somebody saw it and said, hey, I'm going to steal this and put it in my GE turbine, that chance is essentially zero. There is no way GE would allow that to go on internally. So
yeah, and for sure, if it was intentional, I mean, they could have more easily just designed it in a different way. I'm sure that there was another solution available to them that was practically as easy.
Yes,
that they would have gone down that path. But now, obviously everything's designed, manufactured, certified, tested, validated. It's not very easy to change something at this point. Yeah, but I never like to. I never like to see a solution moving forward is that companies are a bit nicer to each other, or nicer to the environment, or nicer to, whatever. I don't trust that companies are just going to be nice, and I would rather, trust that governments and international organizations put rules in place, that everyone knows the rules and plays by the rules. You get the rules right, you don't need companies to be nice, because when can you ever really rely on that? So I don't think that GE is maybe wrong for having pursued their patents. I mean, you spend so much time and money developing them. Of course you need to pursue those, and I don't think that Siemens is wrong for having turned the tables, and I'm sure they feel some sort of schadenfreude about it, and that's fair enough. I would too, but yeah, I think it's business. It's not a couple of kids in the playground. It needs to be sorted out in a way other than just play nicely.
Yeah, and we're seeing the result of that. So I think over the next 30 to 60 days, you're going to see some sort of direction. GE may just say, forget it, we're just going to redesign it. And I think, I'll ask you this, I'm guessing, it's probably like a $10 million redesign in terms of like the engineering time to make the change and get it all implemented. But then it's the recertification part of it. Yeah, I think a $10 million design change turns into $100 million really fast.
Yeah, it depends how. I mean, you don't need to recertify for every design change, but
true.
If you do, then that's expensive and time consuming. Probably people aren't going to be wanting to buy these in the meantime. Yeah.
Bingo. Right. I think Siemens knows that, right? I think it's buried so deep inside that if you change it, you really could affect performance and lifetime. That's my guess at this, having seen a little bit of it, is that Siemens knows they have them. In a sense that they know it's going to be really expensive to change, so they can ask for the sky. Yeah, they can ask for the sky because they know if they had to do the same change on Siemens, how much it would cost. So they have a pretty good idea how much pain it's going to be, and they're willing to take it up to that line. Fascinating.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
Okay, so the next topic is on Orsted, or Orsted, Danish company. I never understand why they chose to change their name from Dong, which was a bad name in English, to something that's totally unpronounceable in English. But they have plans to reduce their emissions from steel. There's a lot of steel in wind turbine towers, obviously, foundations for offshore. So they want to decrease their upstream emissions linked to manufacturing steel. And their plan for that is basically to, instead of using coking coal as the reducing agent to get rid of the oxygen from the iron ore, they're going to replace it with either natural gas or biomass. And they say that they're going to be able to reduce emissions by about 20% by that method. So that's good. That's in line with, basically anybody that has any kind of emissions reduction target or any net zero date in mind is looking to reduce upstream emissions. And the changes that they're planning to make, I actually haven't heard of too many projects where they're using natural gas instead of coking coal. But yeah, either natural gas or biomass. It's really similar to the way that we currently make steel. And this is something that I've made a couple of videos now on the YouTube channel about reducing emissions from steel. And yeah, this is the easiest way. It's very similar to the current method. You just replace the carbon that is in coking coal with carbon from natural gas or from biomass, and it happens basically the same, and you don't need to change too much equipment. But you're still, obviously, the reaction when you react carbon with the iron ore, which is FeO2. So you need to get that O2 out of the iron ore. You react it with carbon, then you get CO2, and that goes off into the atmosphere unless you capture it. So you still got carbon emissions, but a bit less if you use gas. I don't even know how much less, minimal less, I would have thought, if you use natural gas. And then with biomass, same amount of emissions, but they were presumably recently captured out of the atmosphere. So you end up with something approximating zero there, although it never is zero because, things are complicated. But yeah, very, very simple swap out. Basically, it doesn't involve a lot of equipment changes, but you are really limited in the amount of reductions. You can't get to zero emissions this way. Then you need to move to other technologies.
But why is Orsted jumping in the middle of this? They're not the really large user of steel. Not shipbuilding has got to be more. Buildings have got to be a lot more in terms of steel. And we haven't heard anything really from the wind turbine OEMs, not that they're involved in tower manufacture all the time, because sometimes they are, sometimes they're not. It seems like it's not a project for Orsted to get involved in. It seems like there's other industries that should be doing this already, and maybe Orsted's just going to decide to buy from somebody that's using what I'll call greener technology, creating less CO2, or maybe switching to electricity to heat the furnaces. Is that where the emphasis is? They're just going to make a decision that we're just not going to get involved with companies that make steel the old-fashioned way? Like I can imagine
I think
a lot of countries still do.
I think it's that. I don't think Orsted are planning to get into steel manufacturing, become a steel manufacturer. That would be absolutely insane and doomed to failure. It says that they can encourage and accelerate the use of electric arc furnaces, for example. Steel producers can switch their electricity to renewable sources. It's all like I assume they have a net zero date in mind. And I think something like 50% of their upstream emissions, their supplier emissions, come from the manufacture of steel. So there isn't a lot of zero emission steel on the market today. There is some. Sweden has some, I believe, is being produced mostly with hydrogen, using hydrogen, which does a similar thing.
Oh, wow.
You still got to react out that O2, but if you put hydrogen in, then you can react and make H2O water. So that's a way that, if your hydrogen production doesn't have a lot of emissions associated with it, then you can end up with low emission steel. Yeah.
Is this a way for Orsted to sell their product back into the steel companies? Because it sounds like Orsted's talking about making green hydrogen, right? Is this a way to sell a product? Say, we're not going to buy any steel unless it's made with our clean green hydrogen? It sounds like a very circular argument, but maybe it's profitable.
Yeah, maybe vertical integration. But they haven't mentioned hydrogen in this this little announcement. But I suspect this is all about, they want zero emission steel. There's not enough available yet. And so then they have to go to their suppliers and encourage them in that direction. The best encouragement is probably in the form of a, higher price that they're willing to pay for this product. I think eventually we won't need that for green steel. Eventually it will compete on its own, but probably not for another 15 years or so, would be my total guess. But you mentioned, or you haven't heard, wind turbine OEMs with the same types of projects, but it will surprise me if they aren't doing something similar. And I don't know why they haven't, made a big deal about it, because they do have net zero targets, right? The wind turbine OEMs, or at least some of them do. I know GE Renewables does. Or whatever it's going to be called moving forward. I assume that they'll take that commitment with them. Steel currently has a lot of emissions associated with it. I think it's like 1.9 tons of CO2 per ton of steel if you make it in the traditional way with which everyone does currently. So we'll see more of that. Yeah, there seems to be exciting technology with steel though. So these technologies they've mentioned here with the gas or biomass or hydrogen, it's really similar to the way we do it currently. And those are, technologies that are pretty ready to be rolled out rapidly. Those are the kinds of technologies steel companies are thinking they're going to use to hit their 2030 emissions reduction targets, which are, for most of the steel producers, they're aiming for about 30% reduction by 2030. But then everybody's got a, zero by 2050 target, and you can't get there with these technologies unless you also try and add carbon capture, which I haven't seen any big steel producers announce that they're seriously investing in carbon capture. Then you have to move on to other technologies, like electric arc furnace is good, but you need recycled scrap steel to feed into it. You can't just use
make it go.
Iron ore. You can't make it from from dirt in the ground, which is which we need as long as the industry is expanding. And then there's a couple of different electrolysis processes that are under development. The most advanced is probably the one from Boston Metal, who I got to tour while I was in Boston near you guys. Didn't get to catch up with you there though. But yeah, so those are more like 2030 and beyond processes. And those ones, once we have, a fully decarbonized electricity supply, those will be, zero emissions processes.
I think we just defined a very Rosemary thing. The age of maturation for anything to do with renewable technology. Well, 2035. Well, it's another 10, 12 years. At that point, it'll be ready to go.
Yeah. And obviously,
it isn't like they invented it last week. Right.
No. Yeah, exactly. I guess it's always like front of mind for me that I talk about these technologies, and I don't want to be part of the problem where I make people think that, I've been called a techno optimist before, and people don't use that that's not a compliment when people call you a techno optimist. What they mean is you're one of those people that thinks that we don't need to do anything because technology will save us. And I do think that technology will save us, but it doesn't mean we don't have to do anything. Like, it takes a lot of work to get technology to the point where it will save us. And, I've been working towards that goal for the last 17 odd years. So, when people get upset, we didn't have to do anything, the technology just happened. It's like, well, a lot of us were doing something. And I mean, you're the same. I don't think that you think that your technology WeatherGuard did not just, look, here's this fully formed technology that's commercially viable. It's a lot of work. So yeah, I do try to balance, the technology is going to be there, but I want to, put it in context so people get the right idea. And if you think we need to reduce emissions before 2035, which I think the majority of people agree that we do by now, then, this is not going to be all steel isn't going to be decarbonized just, because technology says so by that point. So, that's why I always talk about the ages, and they probably sound real flippant, like off the top of my head, just guesses, but usually it's based on conversations that I've had with the companies that are developing these technologies, and I know where they are in the maturation cycle, how many prototypes they've got and how far they've got left to scale up. So it's not based on nothing.
Anything non-software takes time. And it takes time to get the manufacturing right. It takes time to get all the bugs worked out. It takes time to get it into marketplace, to prove itself, to get some case studies. I think our technology is 16 years old, right? So it's able to drive right now. If it were a person, it would be driving right now. And that's what it feels like. It's like, with this thing's obvious. Everybody will be using it next year. And it did feel like that for the longest time. But it just takes time. And I think we I'll put America into this. We Americans think everything is like Facebook. It's not there one day and the next day there it is, and it's got 1 billion users. No, it takes a long time, and you have to realize that great technologies in their infancy, even Tesla. I mean, Tesla's a good example of the same thing. It took them a long time to get their product to a point where average people could, in theory, buy it and appreciate it. The early vehicles were not that great, right? And I think anything manufacturing-wise is always that way. So I'm not sweating whether we're going to get to the steel thing. I'm just glad that we're starting. I think you are too. That it needs to start now. If we're going to make 2050, it needs to start now, because you're not going to make it if you don't. All right, Orsted involved in another project. They are looking to seed wind turbine foundations towers on offshore with coral. So coral reefs harbor about over 30% of all known marine species are right there on the coral reefs, which was amazing. I didn't know is that much of the organic living creatures in the ocean are actually on coral reefs. That's a lot. And they're saying that the coral reefs benefit more than 1 billion people through their ecosystems. I guess fish eat the coral reefs, we eat the fish, the cycle continues. And that there's roughly $3 trillion per year in natural infrastructure, food security, tourism, medicines that come from coral reefs. So Orsted is looking at seeding the wind turbine foundations jackets with coral to see if it'll stick. Now, this is taking place in Taiwanese waters, and they're going to try it on 4 turbines to see how it goes, and they're going to monitor it for a little while. But this is, I think it's being run out of Australia, Newcastle University. Is that around you, Rosemary? Newcastle University?
It's about 4.5 hours north of me. Yeah, I was there recently. Okay. Built there's a ton of cool tech projects coming out of that university. Yeah.
Wow.
Yeah, so that's not surprising.
So So they're saying that the turbine structures have a unique environment for coral to grow because it's close to the surface where they can get sunlight, which obviously helps them grow, and it has a proper temperature. So it's going to be, I guess, kind of warm and sunny for coral reefs. So this is a new trial. Now, I think everybody in America would say, "Oh, that's crazy. Putting coral on a wind turbine is going to cause problems. It's just eventually going to cause problems. It's going to degrade the towers, and it's almost like one of the concerns to hear from the fisheries is if a wind turbine were to expire, stop using it, what are you going to do with all the jacket? Everything is sort of below the waterline. What would you do? Well, if you seeded it with coral, the chances of you moving it are zero because the environmental impact with that would be significant. So does that essentially make these foundations permanent? And maybe it does. And maybe it's better for the fish anyway. And maybe it creates more of a habitat for marine life to grow. Any thoughts there, Rosemary?
Yeah, I don't see the huge problem with leaving that sort of stuff in place afterwards. We've been putting stuff in the ocean for a long time as, shipwrecks that are hundreds of years old, and, there's a great locations to go scuba diving because, animals love it. So it's that to me is not a huge risk. It's impacting the environment in some way, but has it so far. The evidence doesn't suggest that it's causing massive problems. Yeah, I think this is an interesting project, and in some ways obvious, but obvious once you hear that they're doing it. And it is kind of obvious that it's coming out of Australia, actually, because we've got the Great Barrier Reef, the longest coral reef in the world. I'm pretty sure. Definitely the best one, I'll say, as a non-biased Australian. We've got some other coral reefs as well. Okay. But it is amazing. And it's I guess you guys haven't been to Australia, right? So you wouldn't have gone to the Barrier Reef, but it is amazing for the biodiversity there. And then if you just amazing part of the world. If you go up around Cairns or further north, then you can also get to the Daintree rainforest, is right adjacent to the, on land next to the coral reef, and that has immense biodiversity too. I read that actually 1 square meter of that rainforest has the same biodiversity as all of Europe. There's as many species in that one square meter, going up. The trees are really tall. Yeah, so it's just amazing place to go if you're a nature lover. But the reef is suffering. There's more and more bleaching events. There's always been bleaching events every now and then, but now you're seeing them, sure, back to back, and just seems like more years than not. There's another mass bleaching event. The solution to that is to, stop climate change immediately and, get rid of the 1.5 or, whatever degrees we're already locked into. But since we can't do that immediately, and no one country can control that, and Australia is not pulling our weight anyway, but, they're looking at mitigation strategies for the reef, and that includes figuring out how that we can rebuild it once the damage is in place. And so there is actually a lot of research projects into how to seed bits of coral reef and try and repair them. So I guess they're taking what they've learned from that and then, applying it here.
Yeah. Have you seen or listened to podcasts talking about reseeding the coral reefs and basically taking pieces of coral reef and then nurturing it in a laboratory to make it more resilient to temperature changes or to environmental changes, and then reseeding it? That's actually happening in the Caribbean. There was a really interesting podcast, and I forget the name of the company, but they were doing this and trying this process to make the reefs more resilient by, I wouldn't call it genetic modification, but that it's what it sounded like to me.
Selective breeding, so I guess.
Selective breeding. I think that's essentially what it is. Yeah. To then repopulate, and that it is. There were some companies that were actually funding that effort. So it isn't like this is new. It seems like there's a lot of money and time and effort being researching into this. I think it was happening at Yale University, of all places, that they were trying to bring this technology to bear and make the reefs more active. And maybe this is something that Orsted could use to, instead of just basically transplanting existing coral reef and organisms, maybe they could, breed a superhuman version of a coral reef that could withstand some of these environmental changes that are about to happen. I think it's interesting that you can even conceive of that, right? I think there was, I would say 2 years ago, even sort of pre-pandemic, that most people would say the coral reefs have no shot, that they're just going to be wiped out over time. And I don't think that's the case anymore. I think there's a shot.
Yeah, I'm really scared for our reefs. And last year or something, our previous government, we've just changed government in Australia. So we had a conservative government. Now we've got a more progressive government. The previous government had announced this, huge amount of money to save the reef. And then it turned out that the bulk of that was for a kind of project like what you're describing, where, it's not humans that need to change our behavior to slow climate change. It's the coral that needs to change, So I was kind of, I think most of us just rolled our eyes, because it's like, we thought that you were, doing something for the reef, but we should have known better than to think that you were actually going to try and stop damaging the reef. Yeah.
Well, you hear two projections, though, right? I think there's different projections on what the ocean temperatures will be. You see this sort of rapidly increasing, unstoppable ocean increase. I think you have to be able to negotiate those waters just as well as, controlling CO2 emissions and stabilizing ocean temperatures. I'm not sure if anybody has a real lock on that. But I would rather hedge my bets than not.
No, I agree. But it was just like a bit of a eye roll moment, I think, collectively. Most Australians that care about the reef were like, oh, this is what you meant when you committed however many $1 million to the reef. I mean, there have been good things done as well, because climate change isn't the only problem that the reef has faced. There's a lot of issues from agricultural runoff and stuff, and there has been a lot of hard work and successful work done there to, reduce that. I haven't seen as many, like in recent years, they've been trying to, dredge parts of the reef to make, huge coal export ports. And I haven't heard so much about that recently. I think it's kind of stuck in, I think it's borderline economic, and there've been, some legal action that's been, delaying it. I don't think it's been definitively shut down yet, but that we're at least doing less often actively harming the reef now than we probably were 5-10 years ago. But you got to go there and see it. I think because it's like, this. It's a miraculous ecosystem. It really is. It's like nothing you've ever seen before. I mean, there's other coral reefs and good ones, and they're all, different, unique in their own way. But, you see, like, how on earth did this ecosystem manage to evolve to be like this? It's so, balanced with all these species playing together. I mean, you've seen Finding Nemo, right? So you know about the clownfish and the anemone.
We know all about that.
Yeah. And then, because of climate change and other, just stupid behavior from humans, it'll just be gone. That I just find that quite devastating. It's that sort of, protecting those special environments. That's the reason why I personally am involved in renewable energy, because it's just not acceptable to me that this amazing thing exists and we're just trashing it. So, I want to see every action to protect these reefs.
Well, that's why you named your company Pardalote, right? It's named after the Australian national bird. So
it's not our national bird. I don't know what our national bird is, actually. The emu, I guess.
Is it
on our
not
coat of arms.
Pardalote?
No, Pardalote's... No one even knows what a pardalote is. Just this tiny, tiny bird. It's like weighs 6 grams, and they're common. They're not endangered. They're doing okay, but they hide up fairly high in the trees. So they're, once you know what you're looking and listening for, they're quite easy to spot when you get out in a bit of bush. But no, not our national bird. But if I ever become Prime Minister, then I'll lobby for change. I don't think it would be popular because no one knows this bird.
Rosemary, I don't see you being a really good politician. I think that's one thing that you just
but
can't.
My tact, my immense tact.
You're a great engineer. That usually means not so good at politics.
I'm sure that I would hate it. So I probably won't be Prime Minister, and we probably
I'm sure you would too.
We probably won't rename our national bird after my consulting company.
So if you want to see what a pardalote is, just go to Rosemary's website, pardalote.com, right? Isn't it pardalote.com?
Pardaloteconsulting.com. Yeah.
Consulting, sorry. Pardaloteconsulting.com. You can check it out there. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please take a moment and give us a 5-star rating on the platform you're listening to us on. Be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.